So Lenz's law, we talked about Lenz's law and the fact that there's induced currents when there's a change in magnetic flux. And we had talked about the eddy currents previously in class when we were talking about magnetic braking. Here's a little demo of that. What I've got here is a piece of aluminum flashing, just like a thick piece of aluminum foil essentially, or a thin piece of aluminum. And you can see that, that'll swing back and forth, that big piece. And also I have another piece that's just like it, but it has slits cut into it, okay? But it'll swing as well. As a matter of fact, if I swing them together, you'll notice they swing back and forth pretty much together. So there's nothing causing these to stop. So now if I bring this magnet over, okay, and we know that the aluminum is not ferromagnetic, so it doesn't stick to the magnet here, this horseshoe magnet, right? But we do know that eddy currents will affect the motion of these two pieces of metal, and I can show you that. You can see that, if I can get it to swing through there cleanly, that the big disc, or the big plate without the slits in it, stops almost right away. I mean, it basically, I don't even think it swings through. It just kind of comes in and slows to a stop because of the eddy currents, and they can take a big route. This one, on the other hand, actually can swing for a little while in that magnetic field before it stops. And the reason for that is the eddy currents are confined to these little strips. And so the eddy currents cannot be quite as large and have as big an effect on the motion. And so this idea, you can see that, if you want braking, you would use something like that. And I mean, that's actually pretty dramatic. Let me see if I can just do that one separate. I don't know if I can here. Whoops. All right, you can see that one doesn't want to go through the field at all. This one will go back and forth a few times before it stops. And so this idea